All right, then welcome everybody to this community session from the Gardener project. My name is Tim and I will be presenting this session together with Raphael today. And the session is going to be about provider local. So a short recap on last year, I guess in December somewhere, we had a community session where we presented some results of a hackathon together with our Metal Stack friends. And one of the outcomes was the so-called local provider, which finally allows us to deploy and develop Gardener completely locally without any infrastructure. And we now progressed on the topic, made it a bit more stable and usable, documented it, and so on. And that's why we want to have this session today. This is going to be a hands-on session, so there won't be any slides or anything. We want to encourage you to try it out along with the session and ask questions or tell us if you face problems. So let's dive straight into it. There are two guides for using provider local. And the first one is this one here in the docs, which is about deploying Gardener locally. This is the guide that you can take a look at if you want to try out Gardener really fast. And this is what I'm going to run through now. There is another guide that sets you up for developing locally with provider local, which we will also take a look at later on. And Raphael will show a demo of that. So goal is for this session that everybody can successfully create a local shoot cluster, so a Kubernetes cluster managed by Gardener on their machine. I hope I won't be too fast, so ask questions, interrupt me if you can't keep up. Otherwise, there will also be a recording and you can check it out again or take another look at the guides. Okay, then let's get started. This is basically the target picture that we want to set up now. We will take a look at this in a few seconds. But first, let's start creating and deploying some stuff because it will take a few minutes and then we can check that out. If you want to run along this demo, you might want to make sure you have the prerequisites all set up. Our recommendation is that you give your Docker VM at least 8 CPUs and 8 gigs of memory. Otherwise, all the components will probably slow it down significantly and might not work. So that's a recommendation. If you haven't already done so, you might go to the settings of your Docker VM if you're running on Mac or Windows and give it some more compute resources. Also, it might be good to configure at least some 120 gigs of disk size for the Docker VM. We have faced some issues with that if you don't give it enough disk space. Okay, if you have done these, then we can get started. Only requirement now is to have the Gardener repository cloned, which I have already done here. And I will now start with creating a kind cluster using the pre-configured make target, which is kind up. This will use the kind tool, which is Kubernetes in Docker. It's a popular tool in the Kubernetes community. It will basically bootstrap a single node Kubernetes cluster in a Docker container and is pre-configured for our use case specifically so that we can run all the Gardener components in it. So this is already done now. What we need to do is use the created kube config. You can either copy it to your default kube config in the home directory, or you can explicitly export the kube config environment variable every time. Remember to do that in every terminal window. For my machine, I have set up an environment variable already for this directory using dir-env, so I don't have to do it. But right now we have nothing deployed on the kind cluster, and we're going to change that now by using make Gardener up. This will pull a few binaries if they are not installed yet. One of them is Scaffold. Scaffold is a tool for Kubernetes developer experience, and we are using it here to basically model the whole flow from building our Docker images all the way through to deploying those with the provided Helm charts to our kind cluster. This will take a few minutes probably, so we can have a look at the architecture in the meantime. So what is happening now? We have our Docker machine or VM, whatever you have. And inside this, we have the kind cluster. And we are going to use this one as a garden cluster and a seed cluster. So just for the recap, garden cluster is where all the shoot, seed, cloud profile, project manifests are stored. Basically the control plane of the Gardener system. And the seed cluster is where our shoot control plane components will be hosted as pods. So for example, Kube API server, Kube controller manager, and also some central components like the Gardenlet that manages all of them. We are now using this kind cluster as the garden and the seed cluster, so we don't have to create two separate ones. And we can manage all of the resources and components on one cluster. So once all of the components are built, we should have the Gardener control plane running in the Garden namespace, which will be the Gardener API server and friends. These will store and manage all the objects. And then a Gardenlet will be deployed to bootstrap the seed cluster, and also our local provider extension, which implements Gardener's infrastructure contracts or the cloud provider specific contracts to basically allow us to create a shoot cluster completely on our machine. So usually we obviously create VMs in our cloud provider infrastructure, but we don't want to do it here. And for creating these machines for the shoot worker nodes, we basically deploy another pod into the shoot control plane, which is using a modified kind image basically. And this is basically a node pod, if you want. So we are doing this Docker and Docker and Docker and whatever layered approach. So this is what we want to have at the end. And hopefully the images will be built soon. Maybe I should have executed that beforehand so the cache is warmed up. While we are waiting, feel free to ask questions if you have any already.
Maybe a general one. What are the typical use cases for this local thing? Are you using this kind clusters, for example, in a CI manner? with the pipeline, or?
Yes, we will also take a look at this later on. We have multiple use cases for it. One would be to allow community members to try out Gardener really fast without needing any infrastructure and not paying for any. One would be to speed up the development experience, which previously always required access to a public cloud infrastructure. And the third one is to run end-to-end tests in CI. And we will see that later on as well. Yes.
Cool.
Okay, this is taking a bit longer than expected, but fortunately, this will only take so long for the first time you execute it. And later on, the images will obviously be already present, or on changes, they will be built a bit faster. And now we see that all our images were built. And the first step is to deploy an etcd pod into our garden namespace, which will be used for storing all the shoot, project, cloud profile, etc. objects. And once that is done, we should see that the Gardener control plane is bootstrapped. For this, Scaffold loads the pre-built images into the kind cluster nodes. This is happening right now. Okay, now it is deploying the control plane Helm chart, and we see the components coming up right now. It takes a bit for everything to get ready because the API server has to get ready first to expose the Gardener APIs. And what we should see now is that we can now talk to the Gardener API just via kubectl as usual, and we can retrieve the resources. Right now there is no project yet, but it will be created anytime for us. Okay, now the control plane got ready. The next step is to load some more images into the kind cluster, and then the seed will be bootstrapped for us. Okay, now a lot happened already in the background. I will walk you through it. Now a project was created for us, which we can use to host our shoot cluster, but there is no shoot cluster yet. It will be created later on, but we should already have a, come on. A cloud profile pre-configured for us, which is used to configure the available Kubernetes versions and machine images. And there should be a controller registration for the extension provider local. This is used to tell Gardener which extension types are available in our system and which types can be used for creating shoots. And just a few seconds ago, the gardenlet was also deployed. And just like the kubelet bootstraps the node object, the gardenlet was now used to bootstrap a seed cluster object, which is not ready yet. It's still preparing. So right now, some system components for the seed get deployed, like logging and monitoring. Okay, and while this is running in the background, our scaffold command finished. So what we basically have is this complete picture, but we don't have a shoot yet. This is what we are going to do next. There is an example manifest for a shoot object that uses the provider local, and we can simply apply it. I will keep a watch on this shoot object so we can observe the progress. And you see it is right now being created. Maybe we can also take a look at the exact status message. Okay, we should now also see some first components being created in the shoot control plane namespace. Okay, there we go. Okay, so the first components of the shoot control plane are starting up, like etcd. So usually this takes about, let's say, 7 minutes total from bootstrapping the Gardener until the shoot is created. Right now it's a bit slower, but at the end we can pretty fast bootstrap a complete Gardener installation and create our first cluster, which was not possible like this before. So that's why we are really proud of it. Okay, so just a few seconds ago, the Kube API server was also deployed and already got ready. So now the rest of the control plane will get deployed shortly. There we go.
Maybe a question in between. Is that dependency, so to say, to the kindest node 121 hard-coded?
Do you mean the version that is used for the kind cluster?
Yeah, for the initial one that runs the garden.
Yeah, it is basically hard-coded in this make file target, but there's no hard requirement to a specific version. So we can also upgrade that later on.
Oh, cool, nice. So if I were to test, for example, with 123, with that new security concept that's supposed to replace the security policies, I could give it a try.
Yes,
Nice.
you could, yeah.
Very nice.
Maybe
Thank
there
you.
are some changes that will give you a bit of headache, but you can definitely try it out. Yes.
Awesome. Thanks.
Okay, so while we were talking, the control plane basically got ready. And right now we are waiting for the shoot worker nodes to be created. So as we don't want to create any real infrastructure, we created this machine pod, which is running again this Docker and Docker approach, will contain all the shoot components later on. So while this is still pulling the image, we can take another look at the guide. So we just created the shoot and are still waiting for it to be successfully created. There is also a simple end-to-end test that you can run against your local gardener if you want to do that. It basically creates a shoot, waits for it to get healthy and deletes it again. And you can also access the shoot cluster, which we want to do now as well. This requires some additional setup because we don't use any public DNS servers. So we have to manipulate our etc hosts file. This is the best we can do right now, and we are still planning to rework that a bit to make it easier to access. But I'm going to do that now so I can access the shoot in a moment. Okay, now I will retrieve the kubeconfig secret from the garden and use it. I have some functions for it, but this is also described here. And now we should be able to talk to the Shoot API server and check the node objects. And as we see, there's one node object which corresponds to this particular pod, still being bootstrapped. Okay, here we can see the Shoot system components that are being deployed. And the Shoot should get ready anytime soon.
Tim, I have a question.
Yep. Yes.
How about the other lifecycle management steps? You're showing us how to deploy an instance. What do I do to temporarily stop the local instance from running, and then how do I start it back again?
Mm-hmm. So kind itself doesn't provide a mechanism for stopping the cluster again, but you could simply use docker stop to stop the kind cluster. But you can also just throw away the kind cluster using make kind down and set it up the next time again. This is all that we have basically. I said you can use docker stop if you want.
I see. Okay.
Okay, now we see that the Shoot cluster was created successfully. All the system components are running. And with that, we completed this guide. And I hope you were able to follow it or will be able to follow it later on. And with that, I'm handing over to Raphael.
Tim, can I ask a question? Or maybe at the
Sure.
end, I'm not sure. The question is basically, what are the limitations of this approach compared to having Shoot using a real cloud provider? I'm sure there are some, so it would be nice to outline them.
That's a good question, and we will also take a look at it later on. So
okay.
I will, for now, I'll postpone the answer.
Yeah, I will show it soon. We have documented this. Okay, and let me now share my screen. Okay, Tim has shown you the document for deploying Gardener using scaffold in a very easy way, just one command to make Gardener up, and then everything got bootstrapped automatically. I will show you a bit a different setup, which is a bit more, not really complicated, but there are more steps that you have to do. The purpose of this is to enable a faster development cycle. Because as you have seen, building the images did take quite some time. It will be faster if you do it now again, because some things got cached and so on. But if you do a lot of local changes in the code and so on, then this might still be a bit too long and just unnecessarily prolongs the development turnaround. So we have a similar document compared to the one that you have already seen, which is not in the deployment documentation folder, but in the development folder. But it looks similar. It has a bit, of course, a different architecture. The main difference here is that we don't deploy the Gardener components as regular pods into the kind cluster, but we will just run them as processes on the machine directly. I will also walk you through this a bit faster because it's in the end very similar to what you just saw. The result in the end is the same. So I will be a bit faster. First step is again creating the kind cluster. I need to first delete my old one, and now I can create a new one. You see there is a different setting here, which is required. Yeah, and then the next step is executing make dev setup. This will, similar to what Scaffold has done, deploy the etcd pod in the garden namespace. So we will do that. It will also register the Gardener API server services. This just happened here. And it will prepare the RBAC configuration for all the Gardener components. Okay, now we have to wait until etcd is up in the garden namespace. And then we can start the API server. So this is now just executing go run, quickly building the binary and then starting it up. So yeah, this here is our API server. And now the nice thing is if I change something here, maybe I change the API and want to test it or whatever, I can just exit the process and yeah, start it again. I don't need to build an image, wait for it being built and deployed to the cluster. This is much faster if you want to develop things. Okay, then the next step is to run the admission controller. Here we have to wait for the API service being available, meaning that the Gardener API server is running, which is happening here. So this should exit immediately. And then we can start the admission controller. The downside of this approach, as you already start to see, and it will become a bit worse, is that you have to open multiple panes here for all the different components. Next one is to prepare running the controller manager. For this, we have to run the dev setup again, this time with creating the webhooks. I will not go into the details. This is a bit special to the setup. But once this is done, we can in this pane then start the controller manager. So next step is starting the scheduler. This is optional actually. You don't have to do it. All right. And then we can run the gardenlet. I usually do this in a larger pane because most of the time the actions of the gardenlet is what I'm mostly interested in. First, we have to register our local environment. So similar to Scaffold, we create cloud profiles and register our provider local extension here. We create the project and so on, all the resources that Gardener basically requires. And once this has happened, we can simply start the gardenlet. Now the gardenlet is starting for the first time, meaning again, it has to bootstrap the seed cluster, bring everything up. And the last thing we have to run is, of course, the local provider extension. So yet another pane is opened here. This is running in sudo mode because it directly manipulates the etc hosts file. So this is shown here. And this will allow you to directly access the created shoot clusters. So you don't have to perform this additional step that you just saw in Tim's demo, where you had to do it manually. in this case, this extension will just do it directly, but for this it has to run in sudo mode. So now we have our setup. Now we can check if the seed is ready. It is. We can check in the garden namespace the pods that are running. You see most of them are already deployed, some are still being created. And now the next step is to create the shoot cluster again, just like in the other demo. Now the nice thing is I can directly interrupt the gardenlet. If I develop a new feature, I can just stop it, do my changes, start it again, let it recreate the cluster with my changes. This is much faster again. Still, we are considering at least to harmonize this a bit, maybe move entirely to scaffold if we can overcome the time constraints a bit. But for now, we still have these two setups. Yeah. There's again such a namespace here in the seed cluster where the first control plane components are coming up. And the rest that will happen is again similar to what we already saw. The API server will be deployed, then later the machine pod. And then we can, as explained here, just download the kubeconfig secret for this shoot cluster and directly use it without any changes to the etc host file. Of course, you can also run the end-to-end tests in this setup if you want. You can delete it like this and tear down the setup or the environment with these commands. So this setup is probably more appropriate if you really want to develop something and change something and quickly test it, but you can also do this with the other setup. So you can similarly develop your changes, then just run make gardener up again, and then everything will be deployed to the client cluster with your changes. It will just take a bit more time, but if you think this is a bit too complex or messy in these terminal windows, then you can also go with the different setup until you got a bit more familiar with everything.
Perhaps a hybrid mode would be interesting. If you can run just some of the gardener control plane components on the kind cluster and run for, let's say, gardenlet locally, because you're only interested in changing gardenlet.
Mm-hmm.
Not sure how hard it would be to have such a feature.
Yeah, interesting idea. So typically, what I usually do day to day is I don't run the admission controller because it's not strictly required. And I don't run the scheduler. So this is at least two less processes that consume compute time or whatever. But still, I have always running the API server, of course, the controller manager, and this actually is the extension, and gardenlet, of course. Okay, before we continue, are there questions to this kind of setup? Anything you would like to know or ask?
Yeah, maybe as a comment. You actually received an issue last week from my side, and I automated this process a little bit based on tmux, so that one can simply run a script. It's not perfect yet, but maybe that's a good starting point for someone who wants to do this setup you showed, Raphael, and then one can go ahead and start developing and attaching a debugger to these processes if you like, and do whatnot is interesting. And moreover, I had a suggestion for this sudo command. One could also use lib user host because, well, I personally don't like messing up my etc hosts file with something not really managed by myself. So lib user host would be a good option to have a user specific host file, and that will work as well. So maybe if someone's interested, you can simply check that issue and well, I could also open up a PR if you like. So yeah, let's see where the journey goes.
Yeah, we have seen that. Thanks for summarizing all your work there. We are similarly not happy and also don't like the pseudo mode so much. This is just the very first iteration to get the gap closed, so to say, to have something running entirely locally. And we plan to come back to this whole setup and improve things here and there. Address some of the topics that you already mentioned, but also address some of the current limitations that I will quickly show next. Okay, maybe in the interest of time, I will jump over to this. So we have here in the extensions document, extensions folder document about this local provider extension. And here is a section about the limitations that this setup right now has. I will not go through all of them. Currently we have 9 enlisted here. Actually, all of them are just things that we have not done yet. We are not aware of any technical blockers or any issues that we can solve, just that we have not invested time yet. So first of all is that the shoot clusters that create can only have one node. The reason is that we use the kindnet, or reuse it basically from the kind community, and have seen issues when there is more than one node and didn't look into it. But we are sure that this can be overcome, given that kind also is able to create multi-node clusters. Second is also, since we use kindnet, the network policies are not effective. Kindnet doesn't have any network policy controller. And the same applies as written here for the seed cluster network policies. So not only the shoot cluster network policies, but also the seed cluster network policies. Yeah, then we have a few limitations for using the shoot cluster. There is no persistent volume, so no storage, no load balancer, whatever. But actually the purpose of this whole setup is not to create shoot clusters where you can then again deploy additional workload. You just want to make sure that Garden is able to create such clusters properly, but you will not use them. So that's not too bad, but it still could be improved if needed. For example, by using this local path provisioner CSI plugin that also kind is using or writing a custom cloud controller manager. This actually is this section here. Then we don't have etcd backups at the moment, but there actually already is a pull request implementing support for it. So we will soon have them. And then we have a few, let's say minor limitations. This one about DNS records, then the dependency watchdog that cannot be enabled. Only one cluster when there is the API server SNI feature gate. I say minor because in my experience, those are not day-to-day development scenarios that you often have to check or validate. So yeah, it's not too important for now, but still could be improved. A more, let's say, major limitation is the whole DNS handling that also Tim already, or we discussed already several times with this etc hosts file. Actually, this dependency watchdog cannot be enabled limitation is also a consequence out of this. And also this one, ingresses are not reachable. This prevents using some features like the shoot node logging at the moment. We have not yet used this core DNS that we deploy. We take a look at this picture again. There is a core DNS that we deploy into the kind cluster. This just needs to be extended a bit so that all components can actually resolve the DNS names of the shoot clusters. And then such limitations can probably be lifted. If you see more, then feel free to extend this document. We are quite interested what else does not work, but from our experience from the past quarter or so, for most of the development tasks related to Gardener, it's pretty much sufficient and drastically improves the productivity and efficiency of development.
Can I ask a question about something I suspect might be a limitation?
Sure.
Some time ago, when working on managed seeds and managed seed set, I was heavily using the so-called remote Gardener local setup to work around the fact that with the then available local setup, it was not possible to create a shoot and then register it as seed if Gardener was running on the shoot, Gardenlet, sorry, was running on the shoot. Do you think this would be possible now with this setup? So basically create a shoot and then register it as seed with Gardenlet running on the seed?
That's a very good question. So what would actually happen is that we would just deploy a Gardenlet into this shoot, into this worker node pod, right? And then this needs to communicate to the Gardener API server, which is possible since it's in the same kind cluster.
So you expect it should work, but you haven't really tested it.
I haven't tried it yet.
Okay. I may try it later, and if I see any issue, I will let you know. Thanks.
Yeah, that's an interesting case also for some more end-to-end tests, I guess. So that's a very good question.
We have not really yet tried to really deploy things into the shoot cluster. So the system components are obviously deployed in the kube system namespace. But when Gardenlet then is being deployed as part of this managed seed controller, then it will, during seed bootstrap, populate a bit more of deployments that are also running here in the Garden namespace. I don't know whether this will work out of the box, but yeah, interesting to see the results.
I assume the first limitations there will be that you don't get a load balancer on the local shoot.
I suspect some of the existing limitations will get in the way.
Exactly, yeah.
I will try it nevertheless.
Yeah, sure.
Right. Okay. The rest of the document explains some implementation details of this provider local, how certain extension points were implemented. For example, it describes this etc host file changes that the controller performs and also others. I will not discuss it now, but if you are interested in the details, you can take a look. And yeah, I think I will hand back to Tim for the last topic, the meeting.
Okay, so short recap, what we have seen already. We have seen how you can use the local provider extension to get started with Gardener pretty quickly, just for trying it out. We also have seen how you can use the setup for development purposes and some limitations. And what we have not seen yet is the third use case we already talked about earlier, which would be running it in CI. And I will quickly show that, but not go into detail much. So meanwhile, we have a Pro instance, which is the CI system that also Kubernetes uses. We are still a bit in the experimentation phase, but right now we are running a small end-to-end test suite for every pull request, which is using exactly this local provider setup. And it actually bootstraps a kind cluster in Prow, so basically in a pod, which is then doing this layered approach again. So the turtles all the way down. And then executes a few tests. We can look into one of the jobs right here where all of the tests passed. So right now there are 4 test cases. Creating a shoot and deleting it again is the basic test. But then we also test a few things around hibernation. So creating and deleting a hibernated shoot, but also creating a shoot, hibernating it, waking it up, and deleting shoot. And we also already have a test case for a feature which we are currently working on, which is still in progress, which is the shoot CA rotation. And as you see, this takes about 23 minutes. If we take a look at the PR, we will see that the status is reported here, just like the other pull request verification steps. So if you file a pull request, then this will also be executed for you. And this allows us to catch regressions and bugs much faster than before. And actually just yesterday, we found one regression that we had in the test that runs on master every 4 hours. Yeah, this is a huge step forward for us, for our project, because we can now execute this whole test suite against a complete Gardener installation within a matter of minutes. The next step for this end-to-end test is to augment the test suite. We already have quite some test cases that are executed in the test machinery. I will not go into detail what that is today, but we can reuse a lot of them and add new test cases for this end-to-end test job, which will allow us to gain more confidence for developing Gardener and releasing it. But that's all I wanted to say regarding this CI part. So I would open up for questions again, if you have any.
Tim, this is really cool what you're showing here. Actually, our team is exactly doing the same. So we are testing our Kubernetes operators in the pipeline by creating Kubernetes clusters inside pods. So this is really cool. Maybe if it's okay, I would reach out to you after the meeting. Maybe we can share some knowledge, because we have seen some HCD issues, some slowness there. But this is really, really cool. So we're also driving in this direction.
Very nice. Yeah, if you want, you can also take a look at the configuration of the browser, which is in the CI infra repository.
Cool.
And because we are now reusing Prow, we are able to benefit from a lot of the knowledge and code and configuration that the Kubernetes community already has in place, because they use very similar mechanisms and jobs and so on.
Yep.
Do you have more questions?
I guess we are out of time, so feel free to also use the Slack channel, the Kubernetes workspace, or just ping us directly, whatever you prefer.
To wrap up, I would like to encourage you again to try out the guides as you have seen them here. Check out the recording later on, and reach out to us with feedback, suggestions for improvements or bugs that you find. This will be much appreciated.